Okay, all right. Bye. Hello, very good evening, guys. I hope you all are good. So we'll start our second session in just next 2 minutes. We'll just wait for 2 more minutes because the other viewers they keep coming, and then we'll immediately start. All right. I think I'm audible. If I'm not audible, you can write in YouTube chat. Okay, guys. So I think there are enough people. They have already come, and without delay, we can start our session. So I think most of you, like who those who have already attended our previous session. So I have explained you about the machine learning, the application, and how the data manipulation work, and how the visualization works, and all such thing. So our today's agenda, linear regression, day two. So what exactly we are going to cover? So I will let you know about the linear regression and the correlation, covariance, R squared, and all such thing. Then we'll quickly go through our one case study which is related to linear regression, so that you will have a clear idea, in real world example where and how you can use your linear regression technique. All right. So before learning towards the linear regression, I will let you go through of all this concept, which is correlation, covariance, and R squared. So first of all, why the linear regression and what exactly it is. So basically the linear regression, we call linear regression as a predictive model. Whenever we have to predict something with our historical data, let's say, I would say like a weather prediction. So if I have a like few past like if I have a the past year data, that is historical data. Maybe if I have a 3 year, 4 year, or 5 year data, and the meteorological department, this they are precisely like predict like what kind of weather which should be happen in future, whether the the next year will be on a rainy or maybe a cloudy. Not only like yearly wise, we can predict our weather condition in every hour, in every day, in likewise. And so there are a lot of you can say the sales forecasting and the price prediction, the house prediction, which we will discuss today. Like there's a one very famous US data which is called house prediction data, like how the house price vary from state, from one particular region to region. whether the area is a posh area and maybe the area is like, the less dominance area or whatever it is. All right. So now the concepts, first is correlation, covariance, and R squared. Before explaining all this thing, I would like you to have a look on this, the right hand side, this particular table, wherein you can see sunshine hours and concurrent attendance. So like you can see here, like, let's say in the first 1 hour 90 minutes the attendance was around 22, and if you're going forward you can see in the next 2.5 are the concurrent attendance, which is around 33, and so on. So what exactly it means? So in, like, when the weather is sunny, or maybe like, the initially the weather is sunny, the attendance was little less, and maybe, and when the concert it just keep going and the attendance it just keep increasing, and you can say like maybe 7.2 hours, like, after the, like, after the few hours, like after around 7 hours or so, the attendance was pretty good, which is around 55. So it just keep on adding, like it just keep on adding, like first, in the first initial stage it was 22, then 33, then 30, 42, 38, 49, 42, and 55. So that exactly means like my sunshine hours, if there is a, like, a huge sunny weather, so the attendance would be less. Like as it keep going towards the, like, the sunset, the people will come and join together, like the the more in number, right? So that means is the band makes a loss if less than 3,500 people attend. So see, like, so what is the business idea out of it? So if you have the less number of people, they have attend the contest, so the band will definitely, like, gone for the toss, and they will, it will affect the business, like, like drastically. So based on the predicted hours of sunshine, can we predict ticket sales? Exactly. So like, if we can just target our customer, like let's say in the, maybe the later, sunset hours, and so we can like sales our like tickets on a more value price, correct? And so these are the questions like we need to ask, and discuss among ourselves, like what all are the factors which depend for any prediction. Are sunshine and concurrent attendance correlated or not? So what all are the inference, like, which we specifically get from here? Like, so what I would like to tell you, you don't have to, like, I just want you to just little bit, like, hang off of all this concept when we go through the code and all such techniques. So maybe you will have a more clear idea, like what exactly we need to cover and how you can predict, like, considering the linear regression and stuff. All right. So the inference here is independent variable. So if you can see like any x and y variable, so here I am plotting my graph in the two-dimensional space, which is independent variable, which is explanatory, and sunshine plot on x-axis. So I will just fo- just wait for a moment. Yeah. So yeah, if you can look of this particular figure, concurrent attendance and sunshine. So you can say in my x-axis there is a sunshine hours, and in my y-axis there is a, basically, a independent variable, which is explanatory variable. So that means like every change in my x-axis, which is directly affect to my independent variable, which is concurrent attendance. Like if my sunshine, if my, like, if there is a sunny day, the attendance will be less, and when it keep goes, and when the concert just keep going, the attendance, there is high possibility the attendance just keep increasing. Let's say, like, if the concert has started around 10 a.m., and the attendance would be definitely it is less. Okay, so you can say, let's say, the attendance has started around 10. In the first 2 hours the attendance is quite less, which is around 20, and when the attendance keep going, the when the concert is keep going, the attendance is drastically increasing. You can see here, let's say, like, in the first 8 hours or maybe the first 7 hours, the attendance it just keep adding, like the first 20 people, then 30, then around 44, then 55, then just like nearly about 70, correct? So what we infer from here, so like, so here is a direct correlation. the correlation between the sunshine hours and the concert and the attendance and the like how many numbers are keep attending the concert. All right. Yeah. So this is the typical formula of this equation which we plot for the slope. I think you must have like learned in your elementary school. We need to find the equation of the line. So what exactly we are trying to achieve here, we're trying to achieve the line of best fit. Like you can say there are a lot of different the data points which is given, and how this data point, like if suppose if I have just draw a line or draw a regression line, maybe draw a slope like over here. So so there are more chances it will cross off all these points, like it will touch with all this point. So that is what we need to find. That is why it is called as line of best fit. So there can be many lines. You can draw many lines over here. Let's say the one line is here, one line is here, and one line is just in between, and the just exactly uh intersecting with this data points. So this is the slope. This is the equation of the line of equation, that is y is equal to a plus bx. So line of best, what is the line of best fit? So in the linear regression, we always focus of this particular thing, that is the line of best fit, because there can be many line can be drawn, but what is the best line? The line of best fit is the line that minimize all the distances residual between the actual and the estimated y hat value. What does this mean? The residual formula is basically typically y hat minus y. So that means like what you have estimated and what you have achieved, like what is your actual value. So let's say the distance between this and between the inner line, there might be a few distance, right? So that is called your residuals, like the distance between the actual and the estimated value. Like it will get more clear when I going forward to the slides. All right, so don't get confused. So yeah, this is the typical equation, as I said, like y hat a plus bx, the correlation coefficient. So what exactly we need to find here is that is a correlation, and the correlation coefficient means that is, and we represent as in r. So we always have to find this r. So r is basically is nothing but that is a correlation coefficient. So r is a number between -1 and 1, and tells us how well a regression line fits the data. Like if I'm doing a regression problem, so I need to find the correlation first, whether I'm doing my sales prediction which is correct or not, whether I'm doing my weather forecasting which is correct or not, and like how likely it is correlated with this external factor. Getting my point? Like if the sales is happening, like the sales is happening on considering with all these conditions, like maybe it maybe the month, as you all know, we get our maximum sales in the month of festival season, maybe in the month of Diwali, in the maybe in the month of like Holi, or maybe a New Year or something like that. And yeah, in the closing of the annual year, our sales will always like goes down in the month of maybe April or March, because it's a financial ending year. So you won't expect the much sales. So how you target your customer to excel your sale, correct? So yeah, so this is what I was talking about. So there can be many data points like here and there, but if it is intersecting your data points perfectly, then it's a perfect line of fit, which is called r equal to 1, positive linear correlation. And it can be the slope may be like this. Maybe your sales is going up, or maybe your sales is going down. R equal to -1, negative linear correlation. And if your data is something like that, which is absolutely doesn't make any sense, then there is a no correlation between your independent and your dependent variable. Yeah, hence it gives the strength and direction of the relationship between two variable. So now, yeah, so whatever I have explained you here, it is just clearly written like over here, like coefficient, we called our r as, so r is something which is tells you the correlation among the two variables. And what is coefficient of determination? This is another term as well, which is more or less similar, which is called r square. So it is the percentage of variation in the y variable. In the y variable, let's say this explainable by the x variable, like how much change happen in x, it will correlated with the y. Like every change happen in x, it will affect your independent variable, that is y. Correct? Yeah. Like for example, what percentage of the variation in open air concert is explainable by the number of hours of predicting sunshine, which I was talking about. Like r equal to 0, it means you cannot predict the y value from the x value. So that doesn't make any sense. Like you can't predict anything. But if your r square equal to 1, it means you can predict the y value from the x value without any errors. And the r square is between these two extreme, like minus r, minus 1 and 1. Yeah. So this is the quick summary. So there's a one more term that is called covariance. Before discussing about the linear regression, we have an idea of all this thing: covariance, correlation, and r square. So the covariance is nothing but it will tells you, it is as similar like the correlation, but it will tell you the direction, like tells you the direction of relationship between two variables, like how the two variables are moving together. Like it doesn't give you the magnitude, it will just give you the direction, like how the two variables are moving together, whether it is moving positively, whether it is moving negatively, like that. And the correlation coefficient tells you the direction and strength of linear relationship between two variable, like exactly the perfect, as I told you, the perfect line, which is a straight line. And r square tells you what percentage of the variation in y can be explained by the model, by the independent variable. Correct? Yeah. So now here we jump into directly to the linear regression. So first we'll just go for the definition. So it tells you aims at finding the best fitting straight line, which is also called as a regression line, which I just told you right now. And in the above figure, like the figure you can see here, the sales versus MRP, like how your sales goes up, if what was the MRP. Correct? The red diagonal line is the best fitting straight line and consisting of the predicted score of y for each possible value of x. That means like you have the lot of different the sales price and the different MRPs. But what exactly you need to target? You have to just find a perfect line in between them, which that means you can see in this line there are the maximum number of data points which is intersecting with this particular line. Correct? So that means your line is fitting perfectly. The distance between the point to the regression line represent the errors, and whatever this thing, like the distance between here, the distance between here, maybe the distance between here, maybe the distance between here, or anything which is not intersecting with this line, this is called your error. Understood? Yeah. Hence, linear regression is the simplest and the most widely used statistical technique for predictive modeling. As I told you, whenever you have the prediction problem, whenever you have to identify something, when you have to predict the future, so this is the model, because there are like several models in ML algorithm. So which model you have to use for which particular uh, like uh, uh, like the real world cases. So here we can identify, like if we have the prediction kind of problem, the linear regression fits well. Like it will do amazing job, rather than the any other ML algorithm. So there are a lot of fancy ML algorithm which we will learn in future class, the upcoming class. But here you just need to focus on this particular algorithm, linear regression. Yeah. And variable type, yeah, linear regression requires an independent variable able to continuous, that is a numeric value, no categories or groups. So that means yeah. And one more thing, when we have the problem statement, like in the last class I have told you what is the numeric variables and what is the categorical variable, right? So when we have the numerical variable, so we are specifically use this particular technique, linear regression, because you have the two variables, one is independent and dependent, and they both are supposed to related to each other. Yeah. So here we will study about the algorithm and the interpretation. The linear regression is based on least square estimation, which says regression coefficient should be chosen in such a way that it minimizes the sum of square distance of each observed response to its fitted value. So what does this mean? Like, when you fit your model, so you have to find, like, what is your error matrix, like how, like whether, and like the evaluation matrix, you can say. So there are a lot of terms like, mean square error and mean absolute square error, which we will learn, and like, and in code I will explain you. And the interpretation is like the betas or coefficient, like, like you have seen this equation, right? Y is equal to a plus bx. So here, what is, like, y is an independent variable. Like every change happen in x, it will affect to your y, that is dependent variable. Your a is a constant and b is your coefficient. This is your beta coefficient. That is what we are telling. Yeah, we are talking here. Betas or coefficient of linear regression is in interpreted like below, keeping all other independent variable constant. Like you can keep your this variable as your constant a. Like, so it might be your external, like, factor, which is causing, which is just adding with your linear regression. Yeah. So now, like, what we'll learn, this is the most important thing now, how you will identify, like, whether, suppose you have given the data sheet, and so like how do I approach a linear regression problem? Like you must be thinking, like, when I have the problem statement. See, whenever you are working in any industry or you are doing your own projects, so you will start from a scratch and you will just have the data. You will just have the Excel sheet. You have the rows, few rows and column. So what exactly you need to do with this rows and column? So firstly, like, before building any model, so we'll not jump into the model, like how the linear regression model will work and all such thing. So first you have to spend your lot of time to analyze the data, like what kind of data I have, whether it is related to each other or not. So sometimes it is very difficult to analyze with, like, with just simply, like, just viewing at the data. So that is why there are a lot of techniques come into the picture which will help you to analyze whether this problem is for linear regression or maybe for some other algorithms, right? So what exactly you need to do, you just read your data and you just do your whatever your exploratory analysis, like EDA, exploratory data analysis. And after that, you have to build your visualization. Once you build a visualization, so you will have a ample of, you will have a very, like, pretty much clarity, like what exactly you need to target. So that is what we are talking about here, like ways of testing how well the regression line fits data. Like let's say the residual analysis assumption one. So there are typically four assumption. So if your data look like this, let's say, like if your these all are the data points, so that means it definitely it doesn't fit the linear regression line, correct? So we just discard this approach. But if your data look like this, you can see even though this is a curve, but there are a lot of data points which is intersecting with this particular line, right? So that means we can typically, and you can see the equation here, like this is a use case of, like, when you when you track your walking, when you track your, like, health report or something, like with the mi band, right? Like how much distance you are walking and how much you are ahead with other people. Like you have set the target for yourself and you have also set the target with the among others, like a streaks of days continuously meeting a goal of 8,000 footstep and ahead of the percentage of people. So this is typically like you don't have to dig into all this thing. This is just a basic idea, like, you can clearly see the linear regression line fits perfectly. All right. And this is the second assumption, the error terms are independent or dependent. So I would take you for a moment. You can have a look of these three picture and you can analyze yourself, like what exactly it is telling you, like what exactly you can infer. So if you can see the first picture, so you can see there is a pattern here. I think you must can able to see, right? There is a one pattern. There is a one half sinusoidal wave is forming here, and exactly the same, like there's a one pattern is like forming here as well, right? And this, so that means this is the independent variable. This is not related to with any other thing. So this is the independent variable. And if you can see here, so this is the dependent positive correlation. Like you can see the sinusoidal wave. So what exactly this means, like if you can just not only the straight line, like you just have to look up all these things as well. If any either criteria meets this particular thing, so you can specifically build a linear regression model. Understood? Yeah. And if you can see here, either it is positive, negative, or maybe independent. If you can see, like there is a, again there is a one graph is forming here. Like if you can just like draw a line over this data point, so you can see there is a wave, so which means there is a negative correlation between independent variable as well. Yeah. So plot against any time or spatial variable where order of observation is important. So you will look at of all this thing, and maybe your time series method are more appropriate in such situation than regular regression. So this is your time series, like so every time, like let's say in at a zero time, or maybe at one time, maybe a two time or three time. So every time lapse, that data is keep changing, correct? So these all are the assumptions. So like whenever you have the data of something like this, so you can just have a look and you can get your idea like what, like what approach should I go for. And this is the third assumption called, this is the most important and the widely used assumption, I would say. Assumption 3, the error terms have constant variable, that is homoscedasticity, as opposed to heteroscedasticity. What does this mean? Like if you can see the first two, it will, these two types of like the graphs which will give you the inference of heteroscedasticity, and this will give you the inference of homoscedasticity. Like how? If you can see, like if the data is something, if the data is look like this, and if it is making a tunnel, towards your x-axis, and maybe if you have the data like residuals that show an increasing trend, like if you can see that it will show you the increasing trend, maybe your sales is going up, maybe your sales is going down. And if you can see, like decreasing trend, like towards your, like if it has a more spread, like this is the spread, if you have the more variance, if you have the more spread like towards your y-axis. So these both type of graphs will tells you about the heteroscedasticity, and this is the constant variance. So if you have the data point like something like this, like whether the sales is not going up and down, it is just constant, like maybe for few months, few week, or maybe a few year. So you need to again focus and target our customer and your strategy and planning. So this is called homoscedasticity. So this is something which I was talking about, like RMSE, root mean square error of regression of, or standard error of the estimate, will be misleading, as it will underestimate the spread of some x1 and overestimate for others. So here what exactly we need to understand, that is a spread. Like spread means like how much the variation, how much the variance, these all are the variance, like whatever the spread, right? So why you understand of all this thing, because when you build a model, so you have to analyze your spread, like how much your spread, like how much your variance is vary from one variable to the another, then only you can like infer something, right? And this is the fourth assumption, the error terms are normally distributed. Like maybe if it is perfectly fit, this is the normal and this is the not normal. So we can, there's a one plot called normal distribution, it is a bell shaped curve. I think I have just forgot to mention here, but yeah, if you can, maybe, yeah, I think I've just forgot to mention here, but anyways. So there's a one more assumptions you can tell, that is a bell shaped curve, like you must have seen in the statistics. So it's basically statistics part, so you can brush up your statistics skills, and you can just go through this uh, document again. So if it is forming a bell-shaped curve, then again this is your fourth assumption, which is also called as QQ plot, quantile plot. Yeah. And now this is also like fixing normality and heteroscedasticity. So if you have this problem, if you have your problem with maybe a norm, if your data point, and if your data set, if your graph is normal, then it's perfectly fine. If it is not perfect, if it is not normal, if it is like something like this, so we can use this formation. This is a transformation of data. Maybe you will do the square root or maybe logarithm, etc. Can help correctly normality and unequal variance problem. Because if your variance is like not in a constant form, then it might be the issue. And this is the two last term we have to understand in linear regression, which is p-value and r-square value. Since I have already explained you what is r-square, so we need to discuss here about the p-value. The p-value and r-squared value measure different things. The p-value indicates if there is a significant relation described by the model. Like if any significance. What do you mean by significance? Like there is a p-value called p-value which is less than 0.05. If this was your value, that means we can reject our null hypothesis. All right. So this all are the theory part. It might be a little bit boring, but when you do a coding part, when you like go for your actual use case, so you will understand all this thing, like how we can interpret like p-value, r-square value. I will tell you. So just be with me and don't be in rush. You will understand each and everything. We'll just go like step by step. All right. And the r square measure the degree to which the data is explained by the model. Yeah, so that means like what exactly means like the r square, like as I told you, like how much variation explained in independent variable with the x value, which is dependent variable. And this often happens when there is a lot of variability in the dependent variable, but there are enough data points for a significant relationship indicated. So then like I read this whole paragraph. For this model, r squared indicates the proportion of variability in the dependent variable that is explained by model. That is, an r squared is 0.60. Like when we build our model and when we calculate the r square, it will give us like something like this, like in a point 0, 0.60, point 0, 0.70, point 0, 0.80, point 0.50. So that means how my like whatever the prediction I have done, like how much it is like how much it is predicting my model, like how much it is correct. So 0.60 is not decent enough. It is fair enough, but it is not very good enough. So that indicates 60% of the variability in dependent variable is explained by the model. So that means if your score is around 0.70 or 0.80 or 0.90, that means like your model is perfectly fit and you have done an amazing job, right? So that means the 70% of the variability in dependent is explained by the model. Like as I told you, right, the this use case about the concert attendance and the sunshine are. So let's say like so what we are trying to infer from there, if there is a sunny weather, the people the and if there is a sunset, like after the sunset the more people will come, right? So accordingly you can strategize your sales. Maybe in the evening ticket you can keep more high compared to the morning ticket or compared to the afternoon ticket, right? So if your ticket value, if your ticket size, if your ticket value is like let's say like 1000 buck 1000 bucks in your evening hours, even though the price is high, the people will still come because the people will prefer to come over like like after the sunset. Yeah. Now like before building any model, so this is a generic approach for each and every like ML algorithm. So there is a wise saying like have to put our cart before horse. That means you have to understand the problem statement first. You don't have to jump directly like which model I have to. No, when you have given the data set, so firstly you have to spend a lot of time to analyze the data, that is just an Excel sheet. And what exactly you have to understand data, and what is the business understanding, like what area you need to focus, what area you need to target. Once you understand the business idea, the whole idea, then you can jump to the data understanding, like how the data look like. So whatever the data you get, that is in a very disturbed manner, like it has the like huge null values, like I told you last time about the null value, the none value, and it will have the lot of, like the junk data and all such things. So we will like do our data preparation. So it takes a lot of time, that is called as data the pre-processing steps. Then we'll do our EDA. So in the EDA, like you will do like a lot of things, like to changing your categorical value to the numeric value. You do your visualization and all such stuff, and see like how we can build our model, like building a model, linear model. And once you build a model, so what all are the error metrics which will tell you your model is good or bad. So there is a like a few which we'll discuss like in the coding part. All right. So let me, I think you must have able to see my screen. Yeah, and guys, just hold for a second. Yeah. So this is the use case which I have like took from Kaggle. Like in Kaggle, you can see the ample of like use cases, and this is the one typical use case which I have took about the house price prediction problem. All right. So I think most of you have already aware of this is the Jupyter notebook and how you do, because I think Vinayak has already like took the class and he's explained you about the Python class. So this is the few predefined libraries we have to import before going through our like this concept. So the firstly we have to import the numpy as np. Numpy is basically, as I told you, which we specifically do for our numeric data, like so when you have the numerical data, so we have to use this numpy. And since it's a linear regression problem, so we have to deal with a lot of like numbers, a lot of regression kind of stuff. So that is why we are using numpy as np. Input pandas as PD, that is for data processing, which is the label data. All right, so for pre-processing we have to use our pandas. So these skills are very concrete and very important to have. like how to use numpy and pandas in Jupyter Notebook. Yeah, so there are a lot of other libraries, so you can just have a look. So but we are not going to use each and every library here. We will just use the few libraries. The matplotlib, this is for the plot and stuff, and this is scipy.stats for skewness. Tell you what is the skewness and stuff. And yeah, this is the most important library we are going to use here. That is a import sklearn linear model as linear model. So when you are building any particular model, so you have to import this particular library. Linear model, this is a library for logistic regression. There is another library for random forest. There is another library. Yeah, and this is sklearn preprocessing import standard scaler. Like as I told you, like when you have the lot of variability, so you have to do your standardization, like your transformation, and how it will be done, I will tell you later. Yeah, but meanwhile, like if you guys have any questions, so I would like to answer. Just wait a second, let me just check. So I have getting the request like you are not able to see my screen. So able to see my Python code. हेलो. अच्छा, मुझे वर्ड को मैंने क्लोज नहीं किया था, अभी कर रहा हूँ. सॉरी सॉरी, भूल गया था मैं. ओके. हाँ हाँ. ओके ओके ओके. Okay, guys, I'm really sorry. I think because of this two different, I think you can see my Jupyter notebook now. Am I audible? And can you see my Jupyter screen now? Jupyter notebook. Can you just like drop me a message like over the comment section so that I can get to know whether you are able to see or not? Okay. Okay. All right. So guys, I think like there was a two different windows, though that is why it was you guys were not. I think I have just fixed the problem, and you can see my Jupyter notebook. Okay, so I will just repeat once again, like, what I was. Few of them, like, who has asked me the question, like, how can I get the data set? So the data set, so there are ample of, like, we will share with you the data set and also this code as well. But there are ample of data sets which is available in the Kaggle, so you can go and like, hello. ओके ओके। नहीं नहीं, अभी आपको दिख रहा है कि नहीं दिख रहा है, बस खाली इतना बताओ। Okay, I think guys there is little network problem from my end. That is my voice is breaking in between. Okay, so yeah, so I was talking about like get the data set. So whenever you are working in any industry, so you have to sometime like so you can go and Kaggle and like you can practice and you can just download a data set and you can practice. So here the important is like how you approach. I am just telling you how to approach the data set, how to approach the problem statement. Data set anyways you will get from anywhere. That won't be a issue. Yeah. So I will again repeat of all this thing like so if you can able to see my screen, like import numpy as that is a linear algebra. So the numpy and the pandas, these modes are the most dominant, like the libraries which we specifically use for every whenever like for each and every algorithms. All right, and this good skills to have. So numpy, as again I told you, like it is like precisely used for the numeric data, and the pandas which we used for label data pre-processing. All right, and there are a lot of different libraries, but today we are not going to use all of them. But since it's good to have all of them in one cell, so we are typically using import sklearn dot linear model as linear model. So when you are using different models, so you have to use that particular libraries. Okay, and this is one I was talking about from sklearn pre-processing import standard scalar. So it is always good to standardize your data, right? So now like import training data. So now guys, like today, so this data set is not like pretty much easy. Like so you just have to focus a little bit more to understand this, the whole code concept. In the next class I will try to find the easiest data set which will help you to give the more sense of clarity. But just please for me like bear with me. All right, so yeah, import training data. So these are the typical step which I told you, like what we have to do. First you have to understand the data, then you have to do the lot of data, you pre-process the data, then you do your EDA, that is exploratory data analysis, like you do your lot of visualization, build your model. So building model is just matter of like hardly a few minutes. But the whole approach and the whole idea and the whole time take is to clean your data. Cleaning data is the most important thing, because I told you last time, right? Like it's the whole concept of garbage in, garbage out. If you put garbage, then your output will definitely comes out as a garbage. So that is why, because whatever the data we get from clients, from company, it filled with a lot of junks, and it filled with a lot of unstructured thing. So you have to structure your data first, and then after that you approach your problem. Okay, all right. So this is the typical code for. So this is the argument we are passing, like pd dot read underscore csv train dot csv. So guys, like this train dot csv, this typical Excel sheet you should have in your local system. And I think you must have aware like how to launch a Jupyter notebook. So wherever you have this particular data set, you have to launch your Jupyter notebook from there, and it will automatically read your data. All right. So this particular thing, train underscore, see, suppose if I don't write this, if you just read, not reading each and every cell because it will take a lot of time. So that is why I'll just explain you like what exactly this code is all about and what you should approach, because you can try by yourself. It is showing an error of my files has not been run. It's not worry about because I'll not run the code. Okay, so like as I told you, right, this is your training data, and when you read your data, so you will get a few columns. And see, in the cases what happen is like you will be given by only train data, and sometimes you will given a two data. One is train data and one is test data. So this same import test data, and or maybe reading test data or maybe reading a train data. So when you read your data, test is equal to pd dot read underscore csv test csv. So you can see you have the lot of classes, like you will have the around 80 columns here, like id, ms subclass, m zoning, and a lot of other things, like you have around these all columns. So what happen is like most of the columns which is not relevant, so the less columns you have, you will like build your model perfectly. But what you can do with all this data, like sometimes you have to drop the data, sometimes you have to eliminate the data. And how would you do that, I will explain you in this code. If you can see, because by mistake the code has been deleted. But if you can see, when i when I read this particular train data, so it will have around 81 columns, and your test data it is had around 80 columns, like if you have noticed. Why is that? So that means it has the one additional columns, that is a target data, which is the price, and it doesn't has the price. So what happened is, when I told you last time, it is a problem statement of supervised learning. When you are approaching the supervised learning, you will have the given data. Like you remember I told you the baby example, when the baby have to identify with the apple and also the banana. So if you if you show them the two different things, so it will definitely tell you either of these, either it is banana or it is apple, or maybe a mix or match. So it is similar as this. Whenever you have given, whenever you will be given by any data set, it will have the training data. So what I will do is, don't get confused, next time I will show you the data set. Okay, so how you will identify the target data, what kind of data set you have. Because right now I think there's a little bit problem with my screen sharing, so that is why I am unable to do that. So if I go to the another window, so you might not see my excel sheet. Understood? Yeah. So for a moment, you can just keep in mind. So we have two dataset. One is train dataset, which has around 81 columns. Another one is test dataset, which is around 80 columns. All right. And now you can also check, so these all are the predefined code. So like you can just do your hit and trial, and you can just do your practice, like how to write this code. This is a very easy code, you don't have to confuse, because in python, see, whatever you want to achieve, so with the data type, you just have to you just have to write off all this thing, and it will give you the exact details. Like you can see the print f train has, like the file train has train dot shape 0 rows and train dot shape 1 column. So what exactly you're trying to find, you're trying to achieve, like how many rows I have in my training dataset and how many columns in my have, exactly which I told you. So because manually you cannot check, but this way you can check, like train has 460 rows and 81 columns, but your test data has one less. Correct? And now this is the data summary. So why it is important, so you can understand, because you don't have to do manually, because Python is the statistical tool as well. So you don't have to do manually anything. You can calculate your mean, median, mode, standard deviation, your 25% quantile, 50% quantile, 70% quantile, or your maximum result. Each and everything you can do just by with this code. Train, this is my data type. This is my actual data type. Dot describe dot t. So t means like this is the transpose. So guys, like you can also check, like if you don't understand like any of this code, like what exactly this means, so you can just type tab here. Yeah, you can just type tab here and you can see like what exactly it is telling you. Yeah, so now this is, so it is like all about the pre-processing, like before building a model you have to do a lot of pre-processing steps. So like, and everyone has his own approach, so you have to hit and trial, and you have to like do the because everyone has a different because building model is the same, it has the same code, but in the pre-processing, so everyone has its own understanding. So like that way you can try. So def missing percentage df, this function takes a data frame df as input and returns two column total missing value percentage. So what does this mean? It will, so there are multiple, like you can do this code in a single cell, but in this entire code, like what we are doing in the first code, if you can see here, so we have just passed the one other another argument called total, and df, that is my data frame, is null dot sum short false. So that means what we are giving you the command, we are trying to find the null values as well as keeping them in a, okay, and like all this thing you can do in different cell, but what, like in this code, like what I have done, I have wrote each and everything in a one cell. So if you can see, yeah, so that means it doesn't has any null value, even though if it has a null value, so like because I think it doesn't have any null value, you can see here. And second, we have done the percent, like percent, like how much, so these are the total rows 1453 in pool qc, and this is the 99.52 percentage. So if you can see like all this thing, so this is a typical code, like you can just copy and paste and you can try by your own, like ascending false length df are like find with this multiplied by 100, right? And if you can see like all this are in ascending order, like 99%, 96%, 93%, and so on. All right. Yeah, and this is the skewness and kurtosis. So if I would say what is the skewness and the kurtosis, I will show you the another graph here just to have an idea what is skewness. So these both are the same dataset, but yeah, in this code the approach would be different, and in this code the approach would be different. Just a moment. Yeah. So this is the skewness. So you can, if you can see here, the skewness. What is the skewness? Skewness basically is the degree of distortion from the symmetrical bell curve or the normal curve. Because the more normal curve we have, this is a normal distribution curve which I was talking about, which is also called as QQ plot. If you have this kind of plot, that is symmetrically distribution, like whatever the data set here is here, and the same data set will be given in here. In this kind of normal distribution, always the mean, median, and mode, that is 0. And this is the positive skewness, and this is the negative skewness. Skewness means like the spread. So see, this area under the curve, that is a spread, that is a variation, how much variation is explained by the variable with the dependent variable x. That's the whole concept. So skewness differentiate in extreme value in one versus the other tail. So that means, like, if you can see the tail which is like sloping down towards your right hand side, which is a positive skewness. And if you're slope, because if you plot a number line plot, like it has a -1, -2, -3, -4, -5, -6, like that, and 1 2 3 4 5 6 7 9, so it will give you the more sense. Yeah, so that is called a kurtosis and skewness. So if you can find, the skewness is 1 and the kurtosis is 6, so this is the typical code. Well, like, so what happened exactly is, the more code you will write, it will give you the more sense and the more clarity, like what all you have done and what kind of knowledge you have, but it is not needed as well. Yeah, so here they're getting the correlation of all the feature with the target variable. So as I told you, like, I have the here my target variable is sales price. So sales price is my last column, and what I'm trying to achieving here, I'm trying to find the correlation with all the given variables with the sales price. Understood? I'm repeating again, like, here I am trying to find the correlation between the two variables. One variable is the sales price, and the rest all the variables, which is the 80 columns which is given by us. Like, how much all the factors which is affecting my sales price. That is what I'm trying to achieve. So the data set is whole about the housing price. Like, that in a one region, like suppose in an India, like I have the different states, like Mumbai, Bangalore, Delhi, Kolkata, Pune. So Mumbai, the housing would be a more price, and maybe then followed by maybe a Pune, or then followed by maybe a Bangalore, then followed by maybe a Kolkata. So how much it is correlated with each other. So that is what we are trying to achieve here. So this whole code, like a train, which is my data type, dot CORR, that is a correlation multiplied by 2, like sorry, asterisk 2, sales price dot short value. So I am commanding my code, it will automatically short the value in ascending order, and that is 1. 1 means, like, it is an index. It will start from 1, not from 0, because I have the value from starting from 1. So if you can see, like, all the variable which is 0.62%, 0.5, 0.41, and none of them is 1. So it is not highly correlated, right? All this value, yeah, sales price, which is in data type, which is float. Okay. So what is the observation here? So you need to understand this. Our target variable shows an unequal level of variance across most predictor. If you can see, there is a huge depth. There is a huge variation between each and every, like, variables. The few variables which has 0.006062, and the few which has around, like, pretty much good 0.62. If it is 1, then it is highly correlated. If it is, the more it will be lesser to 1, it is, there is a more chances which is a less correlated. Yep. Yeah. So this is called heteroscedasticity. More explanation below. And there are many outlier in the scatter plot above that took my attention. Yeah. So I told you last time what is a outlier. If you can see in the first few observation, which is more or less like very close, like 62, 50, 41, 38. But if you can see all this thing, like 0.000129, 0.0284, and also things, so these are complete outlier. So if I have more outlier in my system and which doesn't make any sense, so specifically I will drop all this column. So my idea is, the less number of variable I have, my model will fit well, and I will get a more accurate result. So this is my, like, whole intuition. Yeah. So now, like, deleting those two variable with outlier. So here what I have written, like, train.grliv area, like this is my, like, the result, like what, this is the particular area where the housing price, how much the house price is varying. Whatever is less than 4,500 pricing, I will just drop off all this columns. and then I will reset the drop equal to true, in place equal to true. Yeah. So here, like, you can just press a tab here and you can see all the options here, like in place equal to true, in place equal to all, any, and all such thing. And you can just, like, hit and try like what all things are, like, are supposed to be. So if you can just come here and just press tab, so you will see of all this option. Now I have told you, like, this four terms, right? Assumption of regression. Now before building a regression plot, so what all things you should keep in mind? One is linearity, which should be a straight line, whether a model fit wells or not. Second one is homoscedasticity, constant error variance versus heteroscedasticity. Third one is independence of error versus autocorrelation. Multivariate normality, like, whether my model is perfectly fit or not. The third one is no or little multicollinearity. So, like, guys, I have not explained you what is multicollinearity. I will tell you, like, I think one of you has asked about the multicollinearity. What is exactly? So it exactly refers to, like, like when you have the two or more explanatory variable in a multi-regression model. So here we are doing the linear regression model. When I will, like, teach you about the multi regression model, then it, like, make more sense. So the when you have the multi collinearity in one model, like when you have the a lot of multiple variables, so that time, because here you have only two variable, one is x and y, right? So you don't have to, and the correlation between the two independent variable, which is equal to 1 or minus 1, because if you have 0, then that means there is a no collinearity. If you have 1, that is a positive collinear, a negative one, that is a negative collinear. So for a moment, you just keep in mind of all this thing. So now what we'll do, yeah, so transforming target variable using numpy dot log 1p. So there is a, I told you, right, like, there is a techniques, like the more uh, whatever you can play around with your data, like, if you have rightly choose the attributes with your training data, the more accurate and appropriate result you will get. So what does this mean? Like, when you have the little collinearity, when you have the multi-collinearity in your system, in your when you have the external factor which is affecting your training data, so in that case you can do the standard scalar or maybe a logarithm, and maybe in this stuff. Like here I have explained you about, just give me a moment. Yeah, so what you will do, you will just do a log, like train, that is your data type, this is your target variable sales price, you will write in an inverted comma equal to numpy np dot log 1p, log 1p train sales price. So you are doing a logarithm with this thing. So when you do the logarithm, so it will automatically change, like it will transform your sales price, it will transform your target variable, that is the sales price. And now dropping the id, because id here, it is id, it will doesn't make any sense to your training data, and it doesn't make any relevance when you are building a model. So you can specifically drop this column id. So you have to figure out which is the least significant in your model, in your building your model. You can drop that column. because id it's like id will doesn't give you any inference, right? It is not an external factor, so you can just drop this from train and test. And most of the cases we always drop the id, like train dot drop column id x is 1 in place equal to true. So you can try here x is 0. What is x is 0 then? So you can just hit and try, like you know what it will give you the result if it is x is 1. Now saving the target value in white train. So now I have created a one more attribute. I am passing this entire thing in a train sales price dot reset index drop equal to true. So I will just keep on using of this thing, of this entire code in my next few codes. So now what I'm doing, like combining train and test dataset together so that we can put do all work at once. Yeah. So guys, like initially I have the two different dataset. One is a training dataset and one is a text dataset. So when you have the two different dataset, okay, and because you have to analyze only one thing at once, like because you have to just build a model, so you cannot build a model for one is for training, one is for test. It's not like that. So now you will concatenate both this thing. For that, this is the code, like all data equal to pd concatenate train and test reset index. Reset index means it will just give you the, like from the starting from 0, 0 1 2 3 4 5 and so on. Drop equal to true, like drop because we have dropped few column, right? Here id we have dropped, like you know, the few more columns here we have dropped, which has the less than 4500 value. Yeah. So now dropping the target. Yeah, so after doing this, like now in this code all this data has merged together. And what we will do, we will always, because now you are predicting your model, right? So you doesn't need your target variable, because target variable doesn't make any relevance again. So this is the basic and practical approach. Whenever you are building your model, before building your model you have to drop your target variable, like all data dot drop sales price x is 1 in place true. So I will drop my target variable here. And if you can see here in this column, you won't find the sales price because I have already dropped my target variable. So missing percentage and all data. If I'm giving the all data, so in all data, I have already dropped my sales price. So this is the percentage, like you know, whoever are the missing value, also they have the percentage, because I have already found here, right? If you can see this code, like I have already found all this thing, missing data and with the percentage. Here, yeah, missing percentage all data. And now some missing value are intentionally left blank. For example, in an LE feature, there are blank values, meaning that there are no LE in that specific house. So these missing value column, so these all are the missing value column. Like that means like all this column has some or the other missing values. So, yeah. So whenever you have the missing value, so I told you last time what you exactly have to do. So because there are a lot of columns, so we'll create, will, like you know, because in Python you have learned already like the user defined function, like how you used for loop or such thing. So for I in missing value column, all data I dot fill na, none. So wherever I have the missing value, where I will import none, because you have to give something to your model. You cannot just give the blank. You cannot like pass like you know with the blank data, because you have to give something. Only then your model will understand. So in the following features, the null value are there for purpose, so we replace them with 0, right? So now you can change your missing value to 0, because as I told you, your model will only understand the numeric value, right? So you will, whatever the none value you have given, now you can import, that is the imputation method, wherein you can put 0. Okay, yeah. And now replace all missing value in lot frontage by imputing the median value of each neighborhood, right? So here what we have done, all data. So this is my column, lot frontage, all data dot group by. So here I am doing group by. So in what case we do group by? When we have the similar kind of intuition, when we have the similar kind of like data. Because guys, the problem is like I'm not able to show my data. If I would have data, then maybe I can, like, because if I switch the screen, so you won't see the data set. So just bear with me for this time. Next time, like maybe I will show you the data set, the whole data set, once at a glance. Then after that, then I will explain you the code. It will give you the more intuition. But yeah, for that time, let's assume neighborhood and the lot frontage, they must have the similar combination. They must have the similar kind of information. That is why we are doing the group by. Yeah. And after that, what we are doing the mean. Like with these two columns, we are doing the mean. So all this thing we are doing the S type, like categorical to numerical, like we are changing the categorical values to numerical values. So you can just like just have a look, because whatever the categorical values we have, I have told you in the earlier class, everything we have to put in a, see if you can see like the MZ zoning, this has a categorical value, this is the numeric value, this is again the categorical value. So we have to change all this categorical value to, to numerical value. So that is what we are doing here. And also wherever we have the fill NA, we are imputing with 0. Yeah, just ignore all this thing, this is not important. And now you can check, so whatever you have done, so you, like now you can see like I have the lot of now what happened, you can see here, like now I'm checking my shape. So in my train data I have around 81 columns, and in my test data we have around 80 columns. But since we have dropped many columns because they doesn't make any relevance to my data set and to building my model, so I have dropped a lot of data set. Now I have only these many rows and these many data set. The less number of rows you have and the less number of column you have, you can make a like a better prediction model. So now because now my data set has been changed, it's not a train data, it's not a test data, now it is all data, because we have combined, we have concatenated both of the data set, right? Yeah, all data dot drop. Now we can drop few more variables. Now we have dropped few more variables, that is utility, street, pool, QC. So guys, this is all about the intuition, like so there is a no such hardcore training, or there's a no such hardcore like understanding like which column I have to drop. You just have to understand. So when you keep practice, so you will get to know like which columns which is least relevant for me, right? So creating dummy variable. So now what we are doing, we are doing dummification. Now dummification is the method where what exactly we do. So now we have changed. Now I am in this all data, I am passing this all data in a new argument which is called final feature. So dummy variable, dummification is the method where you can change your categorical value to numerical value. And there are similar type of like this kind of practice. One is autoencoder, which we specifically use in deep learning concept. But for machine learning, most of the cases we use this dummification. That is called pt dot get dummies all data. This is my all data reset. You don't have to do this reset and all, but this is just to like your data will just look like a good, like maybe from indexing 0 1 2 3 like that, and drop equal to true. And now if you can check your final features, so now if you can see here it was 89, now it has been changed around 333. So how it happened? Because Now all your values, they have changed into 0 and 1. So that is why the see the let's say, let's assume if the column has, if the has low, medium and high, all right, so it will change as like 0 1 0 or 1, like something like that, 0 or 1. So that is why your column will exponentially increase when you do dumbification. So if you want to understand like how this dumbification work, because in machine learning I don't think so like I will I will like explain you all this thing. You can go to YouTube, or maybe you can do your homework and you can just learn like how the dumbification works. But yeah, this is important to understand. All right, now x, this is the another variable like this. So now this is my final data set. This is my final data type. Final underscore feature dot ilog length y, and x underscore sub final ilog. So like it doesn't give any sense, but yeah, you can do that if you want. Yeah. So now we'll directly jump into our model fitting. So here we can just finally check x underscore shape. Okay, this is also not needed. So you can just focus on this line, this chunk of line, the cell 37, train test. From sklearn model selection import train test split. So what happened is, because in my now in my data type I have two different data set, one is train and test. So what I will do, what we exactly like need to do here, we need to split the data. Why we need to split the data? Because one is test data, which is the actual data, and what one is the training data, which I am like training my model, which is just the assumption, which is actually the like the hypothetical assumption. So that is why we have to split this data. So this is a generic approach we'll do each and every time. So x underscore train, x underscore test, this is the similar code you can use always, like for x train test, y train test, and now you can split train test split x y test size. So guys, see, like so the approach is very concrete and similar. You have to do your data pre-processing, you have to do your EDA. If you want, you can do your visualization. If you do your visualization, it will give you the more sense of clarity to understand your data. After that, you just have to build your model. So this chunk of line you can use each and every time. But the most importantly, like what all pre-processing steps you have done. Like as I told you, like categorical to numerical, from logarithm transformation, finding the missing value, and then imputation, right? So the engineering. So whatever things you have done, then after that importing necessary models. So now whatever the models you have to build, you just have to import. Since we have already like mention of all this import thing in my first chunk of code, but again you can write all this thing from sklearn linear model import linear regression, sklearn dot matrix import mean squared error, mean absolute error. So these are the model evaluation. As I told you, once you build your model, you have to evaluate your model, like how perfectly your model is. So now call in the linear regression object, linear regression normalize equal to true, and jobs equal to -1. If you don't mention this, doesn't make any difference. That's fine. Fit train and test data. So this is the typical code every time you have to use when you use your linear regression model. So this is the argument which I have passed here. Lin underscore reg linear regression dot fit x train y train. Now you must one question must be running in your mind, like what is fit? So when we fit the model, what we really doing is choosing the value for m and b. What is m and b? Like I have told you the equation, right? Y equal to a plus mx. So a is like is a constant, b is a coefficient. Like so y is equal to m plus bx, which is a slope and the intercept. The point of fitting the model is to find the equation, because whenever you are trying to fit your linear model, what exactly you are doing, you are trying to find the equation. This equation should be satisfied each and every time when you are building a linear model. that is y equal to m plus bx, to find the value of m and b such that y equal to mx plus b. Because here, okay, like let's say it's reverse. B is a constant, m is your coefficient, x is your dependent variable. Every change happen in x will affect your y. Describe a line that fits our absorbed data model. Because linear model, the whole idea of the linear model is how your line is fit with the data points, perfectly fit. Once you fit the model, once you fit your data, now you have to predict. For that, this is the code. Why predict? Like this is the again the argument, linear regression dot predict x test. Now guys, each and every time keep in mind, we have combined our data, the different data. One is train data, one is text data. After that, we have merged both this data, train data and text data. Then again, we have split the data, text data and train data. We have split this data. Then we just fit our model. After that, we have to predict our model. You always have to predict your model in your text data. That is why it is mentioned as text underscore x underscore text. Correct? Yeah. So yeah, this is all about like for today's class. And so if you want, you can find your get average squared error by comparing predicted values with the real values. So guys, here I'm not running my code, because if I run my code, it will give me the error, because I have not installed the data set here. That is why I'm not. If you run the model, so you can see, like, it will give you the like pretty much good prediction rate, like maybe a 70 or 80 or more than that. So these are the evaluation metrics, like get average squared error, that is MAC, mean square error, by comparing predicted values with the real value. So whatever you have predicted and how much which was actual. But yeah, like all this thing, like maybe I can explain you in a next class. So that's all for the day. So meanwhile, quickly, if you have any question, like with the theory part, so you can ask me. I would like to explain you. Let me just. So guys, like I think that's all for the today's class. If you have any questions, so you can put below in the comment section. We'll acknowledge it. In the next class, like what I will do is I will make you understand the logistic regression with the use case, and I'll make sure, like will have the data set handy, and then I will explain you. First, I will explain you about the data set. Like you can have a quick glance at the data set. Then maybe probably we can jump into the code. I hope you enjoyed the session. If you like the session, please subscribe our channel and just comment below what you like and what improvement you want to see in a next class. Thank you so much. Have a very good evening. Bye bye.